All right, guys, so this is going to be an overview of the notes we went through on day 1 and 2. I'm going to try to keep this video a little bit shorter than normal, but I still want to get those who may have been absent caught up. So, of course, we have some vocabulary here, right? What we call this number that is the type of root that we have, we call that an index. Of course, you know our radical sign, right? And underneath, it's not a radicand, it's a radicand. Right? That's the radicand. We want to solve these radicals, just simplify these radicals just like we would anything else. If it's even, right, of course we have a plus or minus. A plus or minus. Now, if it's odd, over here at the cubed root, right? Our index is 3. We have an odd index. We don't need any i's. This is just -5. Because I know, right? -5 cubed. Well, that's just -5 times -5 times -5, which gives me a -125. Because it's odd, I only have one type of root. And just like we can over here on our square root, where we can distribute our radical to the numerator and the denominator, getting a plus or minus 2/5, we can do that with any type of root that we have. So over here, the cubed root of, we'll do a -1, is just -1. So this becomes -1/3. Over here, our fourth roots. Now we're back into the plus or minus because it is even. So the fourth root of 1 is plus or minus 1. Over here, right, we can do the exact same thing. The fourth root of 81 over the fourth root of 16. The fourth root of 81 is, let's see, is that 3? Fourth root of 16 is 2. 3 times 3 times 3 is 27. Times 3 is 81. So on our guided notes portions, right, if you have an even index, you know you have 2 types of roots. I don't like red, let's go blue, right? Two roots, and they're both real. When it's odd, right, you only have 1 root, and it is real. So up here, remember we'll have a plus or minus. When the index is even, on odds, we just have 1. If it's a negative number, radicand, under that radical, right, we still just have 1, and it is a negative number. Now if it's even and it's negative, that's where we have to use our imaginary numbers, right? And if we're making them up, we're gonna have 2 made up roots, right? So remember how we solve, how we simplify roots. We wanna factor, right? And then we wanna take out by the number of the index. So let's go ahead and jump over here to number 2. Here I have the square root of 320. So I can simplify that down to 32 times 10. 32, I know I can simplify down into 16 times 2. 10, I can simplify down to 5 times 2. 16, of course, simplifies down into 4 by 4, which is 2 times 2 and 2 times 2. So what I'm left with over here, right? I have this 5 that's all by himself. I have a pair of 2's here, a pair of 2's here, and a pair of 2's right here. So all of those are gonna go outside the radical. So 2 times 2 times 2, right? Don't forget, I also have to multiply by my coefficient I have out front, which is a 4. And what is left under the radical? Well, what was left over? Well, it was that 5 right there. So we're gonna have a 5 here. When I multiply that all together, 4 times 2 is 8, 2 times 2 is 4. So I get 32 root 5. All right. So now let's talk about our cubed roots. So when we have our cubed roots, same thing, we can factor, but now we can only take out in 3. So when I'm simplifying my cubed roots, I'm looking for triplets, 3's, right? So here, I can factor just like normal. I know 108, to make that, I can do 2 and 54. Right, which I can do 2 and 27. And 27, I can do 3 and 9. And 9, I can do 3 and 3. So the only set of triplets I have is right here. I have my 3 3's. So I have 3 that I'll be able to take out. Don't forget, I also have my 3 that was my leading, that is already outside. And then underneath the radical, we'll do black, right? I'm left with these 2. Remember, those are multiplied by each other as well. So on this one, I do end up with 9 root 4. No plus or minus. We have an odd index. So you're simplifying just like normal on your cubed roots, just like you would. The only difference is now we're taking out our factors in triplets, in groups of 3. So let's do a 4th root now. So, there we go. All right, so a 4th root. All right, over here I have 3 times the 4th root of 162. Well, I need to start breaking that 162 down. I have an index of 4, so like my index of 3 that made me do triplets, now I have to take out in groups of 4. So again, I can start, it's even number, so I can start dividing by 2. 162 divided by 2 is going to equal 81, right? That 81 I know goes to 9 and 9. Those 9s go to 3 and 3. So I have 1 quad right here. I have those 3's that can go outside. Don't forget that I do have my 3 that was already out front, right? And what am I left with? Well, I do have this 2, right? That was lonely, didn't have anybody. And remember, this is a 4th root. So my answer now is 9 4th root of 2. Remember, your roots always stay the same. If I didn't put my 4th root there, make sure you put your indexes, right? When you're working, your index tells you how you must take those factors out, the groups that you need. So now let's talk about with variables. When I'm working with square roots, my variables must be taken out in multiples of 2. My exponents of those variables of cube roots must be taken out in multiples of 3. And my exponents must be taken out if it's a 4th root in multiples of 4. When you think about it, if I have x to the fourth, and I have the square root of that. Another way I could write that is x to the fourth to the 1/2, right? If I have something that's a square root, I can also say that is to the 1/2 power. Well, knowing our exponent rules, if I have an exponent to an exponent, I multiply. So this becomes 4 times 1/2, right? So my answer here will be x squared. 4 times 1/2 is 2, so that becomes an x squared. You can think of these as dividing by the index. Remember, if there is no index, we always assume it's a square root. So here, first, I'm just gonna work with my number, right? 32 is just 16 times 2, which is 4 times 4, 2 times 2, and 2 times 2. My index is 2, so I'm looking at pairs here. How many pairs do I have? Well, I have a pair right here and a pair right here, and I'll be left with a 2 under the radical. So I know this is going to be 2 times 2, leave some space for my variables here, right? And a 2 is left underneath my radical. Now I have x to the fourth, right? Well, what is 4 divided by 2? It is 2, so that becomes x squared. And I have 9. What is 9 divided by 2? Well, it's 4.5. So I know I can take that whole number out. And how do I express y to the 1/2? Well, I can put it underneath my square root, right? That represents my y to the 1/2. One way you can always check to make sure you have the correct amount of exponents, right, is you take your exponents outside, you multiply them by your index. So here I would have x squared times 2, which is 4. No x's underneath, so I should have an x to the fourth under the radical, and I do. I have y to the fourth times 2, that's y to the 8th, plus 1 is 9. And that is what I started with underneath the radical. So the answer here, multiply your coefficients, is 4x squared, y to the fourth, square root of 2y. All right, let's do a more complicated one with a cube root. So number 12 here. On number 12, I have a cubed root of 56, r to the 8th, s to the fourth. So I can factor my 56 and look for those groups of 3 that I can take out. I know 56 is 8 times 7. I know 8 is 4 times 2, and 4 is 2 times 2. So I do have one triplet right here. So I can take that out and put it in front. I know I'm going to be left with a 7th underneath my cubed root. So I can draw my cubed root. I know I'll be left with a 7th. Now I have r to the 8th. So what is 8 divided by 3? Well, it's 2 2/3, 2.66, right? So I get r squared. Now I need 0.66. Well, I'm working with thirds. I know that's 2/3, right? So I must have an r squared underneath the cubed root, right? You think about it, right? I have r squared to the 1/3 power. So that, if I multiply those out, is r to the 2/3, right? Which is what I need. S to the fourth, well, 4 divided by 3 is just 1 1/3. So I can take out one s, and I still need one more s. And so I have an s underneath the radical. So you can double check to make sure you have the correct exponents. Well, 2 times 3 is 6, plus 2 is 8, and that is what I started with under the square root. S to the fourth, right? So I have s, the 1, right, is there. 1 times 3 is 3 plus 1, and I have s to the fourth. So my exponents do check out. So my answer is right here, 2r squared s cubed root of 7r squared s. So that is simplifying our roots with exponents. Hopefully you finished that homework. Now let's talk about adding and subtracting radicals. So very similar to how I add and subtract my fractions. If I have a 1/2 plus a 1/3, one of the first things I need to do is get a common denominator. Right? So over here I would just multiply my 2 by 3, top and bottom. So I would get 3/6 plus multiply by 2, 2/6. Then I just add across the top, leaving the denominator the same. So I would get 5/6, right? Similar to how we multiply fractions, right? We have to have things in common. We have to have the same index and the same radicand. Remember, your index is our number right here, right? What kind of root? Have to have the same, and we have to have the same number under the radical, right? That's the radicand. So number 1 over here, I have 3 square root of 27 minus 2 square root of 12. Well, I need to get these to common, I have the same indexes, but I need to get them to common radicands, right? The common under the radical number. So I can start simplifying 27. Well, I know that's 3 times 9. I know 9 is 3 times 3. It's a square root. So I can take out in groups of 3. So I'm going to get a square root of 3, a radicand of 3 here, right? So I'm going to need to make my square root of 12 have a radicand of 3. So this term becomes 3 times 3 times the square root of 3, right? It's going to be subtracted by this term over here. I can simplify 12 into 3 times 4 and 2 times 2. There's my one pair. So this becomes 2, right, times my 2 that's out front, and I'm left with a square root of 3. So now the question becomes 9 square root of 3, 3 times 3 is 9, minus 4, 2 times 2 is 4, square root of 3, and it's just 9 minus the 4. So this becomes 5 square root of 3. All right. Now over here, I'm dealing with, on number 2, I'm dealing with cubed roots, right? I need to get all of these to the same radicand, right? They all have the same indexes, so that's good. But I still need to get them all to the same radicand. I know there's a 2 right here, so I'm probably going to get these all to the cubed root of 2. So start working on 54. All right, well 54 is just 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. It has an index of 3, so I'm looking for triples. So I can take those 3's out. So this becomes 3 times 3. And I'm left with that square root of 2. Minus, well this one's already solved for me. 2 square root, cubed root, don't forget your cubes, your indexes. Cubed root of 2 plus, now I need to get this negative 16, and this is important, right? I can't have a negative under here. I have to have the exact same radicand. So I know I'm gonna need to pull that negative out. I know 16 is 4 times 4, and it's 2 times 2, and 2 times 2. I'm pulling out triples, so one of these 2 will be left over. I want to pull out a negative number to leave it as a positive 2. So I'm going to get 7 times a negative 2, which is going to be a negative 14 square root of 2. and I was adding this number here. So what I'm left with is 3 times 3, which is 9 cubed root of 2 minus 2 cubed root of 2 plus a negative 14 cubed root of 2. So 9 minus 2 is 7 cubed root of 2 minus 14, right? I get a negative 7 cubed root of 2. All right, guys, hopefully you understand how to add and subtract and simplify radicals. Thank you.